All right, here we go. This is Volume 2, Christos Dynamics, the Structure of Reality. Tonight we're going to start Part 11. Here we go. Also, if you haven't watched the first 10 parts, the Coherence Boundary series, please go back and watch them. You'll find it very interesting. This is Part 11, Why Coherent Systems Must Oscillate. For a long time, I thought stability meant something staying still. That if something was stable, it wasn't changing. But the deeper I look, the more I realize that's not what stability actually is. Because nothing in reality is truly static. Everything that exists moves. Not randomly, not chaotically, but in patterns. Repeating patterns, and that's where this starts to shift, because stability is not the absence of change. Stability is controlled repetition. It's oscillation. And once you see that, everything begins to reorganize. If a system is going to exist at all, it has to satisfy constraints. Not rules in the sense of laws written somewhere, but structural requirements. Conditions that must be met for something to persist. And these constraints are not infinite, they are finite. There is a limited number of ways a system can hold itself together and continue to exist without breaking apart. That means every stable system is operating within a very specific window. Not just any configuration works, only certain ones do. Now here's where it gets important. If something is going to remain within that window over time, it cannot drift. It cannot just move in one direction and hope to stay stable. Because the moment it drifts too far, it exits the conditions that allow it to exist. There we go. So instead it does something very specific. It cycles. It moves away from equilibrium and then returns, away and back, over and over again. That is oscillation. And this is not something we just see in one area of physics. This is everywhere. Waves, vibration, orbits, electrical signals, heartbeats, breathing. Everything that persists does this. Everything. Because oscillation is not just behavior, it is how systems stay within the coherence boundary. This connects directly to what we just established. There is a limit in the system, not a speed limit, a coherence limit, a boundary beyond which structure cannot hold. Now think about what oscillation is actually doing. It is keeping the system from reaching that boundary. It is constantly correcting, constantly returning, constantly maintaining alignment across its structure. Without oscillation, there is no correction. Without correction, there is a drift. And drift leads to loss of coherence. And once coherence is lost, the system no longer persists as itself. So oscillation is not optional, it is required. Now let's take it one step further. If oscillation is required for persistence, then what we experience as time is not something fundamental on its own. It is the measurement of those oscillations. That is what a clock is. A clock does not measure time. A clock counts cycles. It counts repetition. It counts how many times the system returns to a recognizable state. That could be a pendulum swinging, a quartz crystal vibrating, an atomic transition, or even a biological rhythms inside the body. Different clocks, same principle. They are all counting oscillations. And this is where something very important emerges, because once you realize that time is being measured through cycles, you also realize that different systems can have different cycles, different frequencies, different rates of oscillation. And that means different experiences of time. Now go back to relativity. Time dilation. We said the system reallocates updates under constraint, but now you can see it another way. The oscillation itself changes. The cycle rate changes. The clock is not slowing down in some abstract sense. The system is completing fewer coherent cycles relative to another frame. Let me say that again. The system is completing fewer coherent cycles relative to another frame. That's all it is. So now we have something much clearer. Coherence defines whether something can exist. Oscillation is how it maintains that coherence. And time is how we count those oscillations. Now here's where this connects to something deeper. Because if oscillation is required, then it cannot be arbitrary. It cannot be anything. There are only certain oscillations that remain stable, certain patterns that hold, and these patterns organize themselves. They fall in two positions. This is where people start to recognize something familiar because those positions are not random. They show up over and over again across different systems, 12 divisions, 12 positions, 12 repeating reference points in a cycle. You see it in clocks. You see it in orbital systems. You see it in biological mapping. You see it in how we divide cycles to make them usable. But this is not because humans like the number 12. We just love the number 12. It's because 12 is a natural way to partition a repeating cycle into stable, usable positions. It allows for symmetry. It allows for division. It allows for reference. So now what you're seeing is this. A system must oscillate to remain coherent. That oscillation forms a cycle. That cycle can be partitioned into systems. And those positions become the way we describe and observe the system. And this is where everything from the previous series comes back. Because what we called the 12 branches of physics were never separate systems. They were perspectives. They were ways of describing behavior from different positions within the same underlying cycle. Not force, placement. Not motion, selection. Because what persists is not what is being pushed the hardest. It is what remains coherent through the cycle. Now bring this all the way back to the boundary. The coherence boundary is not something far away. It is being approached and corrected continuously. Every oscillation is a negotiation with that boundary. Move too far, you return. Lose alignment, you correct. Break coherence, you disappear. So the system does not wait until failure. It continuously maintains itself through oscillation. And now something else becomes clear. If oscillation stops, time stops, because there are no more cycles to count, no more repetition, no more reference. That is not physiological. Sorry, that is not philosophical. That is structural. No oscillation, no persistence. No persistence, no measurable time. So when you look at reality through this lens, you stop seeing separate phenomena, you stop seeing isolated laws, and you start seeing a system. A system that maintains itself through coherence, a system that stabilizes itself through oscillation, and a system that becomes measurable through cycles. And once you see that, you realize something very simple. Time is not what holds reality together. Coherence is. Oscillation is how it survives. And everything we observe is just a different way of describing that same process. We will pick up on monologue 12. And this volume 2 will be, this will go to part 23. So hope you guys will enjoy it. Hope you have a great night. Namaste. Okay, here we go. This is volume 2, which is Christos Dynamics, the structure of reality. This is part 12. Stability is not continuous. It exists in bands. When I first started thinking about stability, I assumed it worked like a smooth scale. That something could gradually become more stable or less stable, sliding continuously from one condition to another. But that's not what actually happens. The deeper I look, the more I realize something very different. Stability does not exist on a smooth continuum. It exists in bands. Discrete regions where a system can hold together, separated by regions where it cannot. And once you see that, everything starts to look a little different. Because it means systems don't slowly drift into new states. They transition between allowed states. They move from one stable configuration to another, and in between those configurations, there is instability. You can see this everywhere once you know what to look for. Electrons don't orbit at any arbitrary distance. They exist in discrete energy levels. Orbits don't just wander randomly. They settle into stable paths. Resonance systems don't produce every possible frequency. They lock into specific modes. This is not coincidence, this is structure. A system can only remain coherent under certain conditions, and those conditions are not infinite, they are limited. That means there are only certain configurations that can persist over time. Everything else collapses. Now we connect this back to what we established. Coherence is the real boundary. Not speed, not force, coherence. So if coherence defines whether something can exist, then stable configurations must be the ones that satisfy that boundary. They must fit within it. They must operate in a way that allows the system to continuously resolve them. And this is where oscillation becomes even more important, because oscillation is not just maintaining stability, it is selecting it. I know you guys have to think about that 12 Branches of Physics Jamaica song I did, or reggae song I did, every time. I do anyways, every time I say that. A system does not randomly land in a stable state. It cycles through possibilities, and the only configurations that survive that cycling are the ones that remain coherent. Everything else falls away, so stability is not given, it is filtered. Now here's where something clicked for me in a way I didn't expect. Because once I started seeing stability as discrete, I started looking at how we actually measure change. And that led me back to something we use every single day, a clock. At first, a clock seems simple. It just tracks time. It moves forward at a steady rate. But that's not what it's actually doing. A clock is not measuring time. It is marking stable intervals. Each tick is not time passing. Each tick is a completed cycle, a return to a recognized state, a recognizable state. That means a clock is not continuous, it is discrete. Tick, tick, tick. Each one representing a stable oscillation that completed successfully. And that realization changes everything, because now you're not looking at time as smooth flow. You're looking at it as a sequence of stable events, a sequence of successful resolutions. And this is exactly how stability bands behave. A system does not move continuously through all possible states. It ticks between stable ones. It resolves one configuration, then another, then another, then another. Everything in between those stable points is not fully resolved. That's why systems don't smoothly transform. They shift, they lock, they snap into place. Now think about what that means in terms of coherence. Because every stable state is one that satisfies the boundary. It fits within the system's ability to maintain alignment, and it can be resolved consistently. But anything outside of those bands cannot be maintained. It cannot be placed. It cannot persist. So what you're actually seeing is this. Reality is not a continuous field of possibilities. It is a structured set of allowed configurations. And movement between them is not smooth. It is stepwise. Now go one layer deeper, because if a clock is marking stable cycles and stability exists in bands, then the clock is actually mapping those bands. It is not just counting time, it is tracking transitions between stable states. And this is where the overlap begins to show. Because once you look at a clock differently, you start to notice something. It is circular, it repeats, it cycles through positions. 12 positions specifically, like the 12 branches of physics, like the 12 constellations, I know you guys are going to say the 12 tribes. And those positions are not arbitrary. They are divisions of a cycle, reference points, ways of organizing and repeating a system into something observable and usable. Now bring everything together. A system must oscillate to remain coherent. That oscillation produces cycles. Those cycles resolve into discrete stable states. Those states can be mapped as positions, and those positions repeat. This is what a clock is showing you, not time, structure. And once you see that, something else becomes obvious, because that same pattern shows up everywhere. Not just in clocks, not just in measurement devices, but in how systems organize themselves. Cycles, positions, repetition, resolution, the same underlying structure appearing in different forms. Now, this is where people usually stop. They recognize the pattern, they see the repetition, but they treat each example as separate. A clock is a clock. An orbit is an orbit. A biological cycle is a biological cycle. But they're not separate. They are different layers of the same process, because what you are really looking at is how a system maintains coherence over time, through oscillation, through discrete stability, through repeatable positions. And this is why stability cannot be continuous, because the system cannot support every possible configuration. It can only support the ones that remain coherent. So it organizes itself into bands, into cycles, into positions, and we observe those patterns through the tools we build to measure them: clocks, charts, models. But those tools are not creating the structure, they are revealing it. And once you see that clearly, you stop thinking in terms of smooth change, and you stop thinking in terms of infinite possibility, and you start thinking in terms of what can actually hold, what can repeat, what can persist. Because that's what really is, that is what reality is selecting for. Not motion, not force, coherence. And the systems that survive are the ones that find stable ways to remain within it. That's why people that have higher coherence will live way longer. Next one coming up, 13, is a clock does not measure time. I've been waiting to do this one for like 7 months, 8 months. So this one is going to be fire, the next one coming up. If this one didn't surprise you, wait till we go into some serious clocks. Hope you have a great night. Namaste.